So many people in the past asked me, where can I learn programming from? So I would hop over on the internet and search for a course for them. It would be a course in Java or JavaScript. Not too long for sure, but I would give them the link and they would be like, but I need something in C because that's what we're doing at school and that's what our teacher is demanding. So I would go back to searching, and what do you know? C courses are only between 10 and 20 hours long, and there's nothing in between that would actually work. And most of the courses are going over some details that the absolute beginner wouldn't even be able to process. So this is what this course is about. The Ultimate Guide in C is something for absolute beginners, and in less than 4 hours you should be able to make your own basic programs, and you should understand basically everything inside of it, because we're not touching on anything that is way too complicated. Okay? As to not get you bored, the course is fast-paced, jam-packed with information helpful for absolute beginners. And even if you're not an absolute beginner, if you still have doubts about your basic principles of programming, you should maybe watch this too. Without further ado, here's the course. Let's get started. Alright, so the one and only thing that you have to install for this tutorial is dev C++. Dev C++ is a place where we're gonna put our code in and execute it. So go ahead and download and install. Once you're done installing, you can open it and you're gonna see this window. You first have to create a project for this, so first thing is just go here, file, new, and project. And here you have to select a couple of things. You have to select in the basic tab, console application. This is what we're gonna be developing through the course of this tutorial. And you'll have to select a C project. So make sure you have these selected and name your project however you want. I'm gonna name it tutorial and hit OK. Then you have to choose a place in which should be saved. I'm going to save it here, and as you will see, it opened another file and it created some text for us. This is basically a template application that can be ran to test if everything works correctly. So if you notice here, there's an asterisk, which means that the file hasn't been saved yet. So hit Ctrl S and save it in the folder you have your application. And to run it, you simply go to execute and compile and run, or just hit F11 on your keyboard. So if I hit F11, it's going to compile and run our project, which is on my other screen right here. For our first project, what we want to accomplish is write something on the console for the user to see. To do that, what we have to do is write in between the open bracket and the return 0 here. We have to write printf, open parentheses, double quotes, and in between the double quotes we say, for example, hello YouTube, and a semicolon at the end. If we try to run this, you'll notice that we have printed on the console hello YouTube, which is really nice. From this you can actually notice the structure of a C statement. It's in between the open brackets and the return 0, and it always ends with a semicolon. First important thing to note here is that each piece of software is made up of two main parts, one of which is data and another is instructions that use that data. Alright, so think of it like on a Facebook post, right? You have likes, number of likes, which is the data, and you have the action of liking the post, which uses the number of likes, for example, adds 1 to it, and does something. It's an instruction to the computer. So what we have to do here is tell the computer that, well, we want some data. We want, for example, an integer, some number, right? To do that, what we have to type in here, before printf here, we have to say int from integer and some name for that data. Let's call it a. Okay, and what that tells the program is we need an integer and we want to call it a, right? And a semicolon would prove the fact that we didn't tell it to do anything else. So if we run this, we won't get any different results because all we did is define that we want to use this data. We didn't actually use it in our instructions. This is just data and it's just there, not doing anything. In order to use that data, first we have to assign it a certain number. Right now it's uninitialized, it doesn't have any sort of value. To do that, we have to say a equals 5. And from that point on, a will be 5 whenever we use it. Okay, so if we run this, you'll notice that we are not printing a anywhere because all we do is just declare that, oh, we want this a to be there, we want it to be 5, but then we're just printing hello YouTube. So what do we do? How can we print the value 5 from a on the screen? Well, let's try a couple of things. We can say a here. Let's see what's gonna happen. Well, we're actually printing the character a, so that's not right, is it? So what we have to do is actually use an identifier called %d here, and after the double quote, the ending double quote here, we have to say comma space a. And then what the program is going to do is going to say, oh, this is a special thing that I have to do, and I have to look after the comma, get a, and paste it in the console, right? That's what it's going to do, and that's how you can print out variables inside your program. So if you try to run this, you'll notice that we get 5 on the console. And you'll better understand this later on, where we're gonna go more in depth with this special identifier. For now, just know that that's how you can print a variable on the screen. Alright, now that we know how to show what the value of a is, let's try and change it to something else. Let's try assigning it a different value. I don't want anymore it to be 5, I want a to be just 1. And don't forget the semicolon. Now if we try and run this, you're going to notice that we now have the value 1 on the console, which is okay. But what if I cut this line of code and put it behind a equals 5? Alright, so what if we first do a equals 1, then we do a equals 5? What are we going to print on the console? Well, if I try and run this, you're going to notice that now we print the value 5. So, one thing to note, in any programming language, the code is ran line by line. Alright, so we first say that we're going to use the variable a, then we assign the number 1 to it, then we assign the number 5, and then we print it. And we print what exactly? Well, whatever the value of a is at the time of executing this line. So even though I did say here a equals 1, because the code is executed line by line, we overwrote that by saying a equals 5. I hope that's clear enough. So keep this in mind. The code is always executed line by line. Alright, so now that we know the code is executed line by line, let's try doing some operations with it. Since you might have heard that the computer is actually pretty good at math, let's try doing some of that right in here. So first let's delete this a equals 5 and let's leave a equals 1. And let's try adding something to it. Let's say a equals 1 plus 2. For example, let's try and print that. Okay, so let's run our program, and as you will notice, the program knows how to do math. 1 plus 2 equals 3, and that's what we printed on the screen. That's great. You can also subtract from numbers. You can also say -1 here, and I will do all these operations, which is 1 plus 2 minus 1. The result should be what? 2, of course. So if we run this, we get exactly 2, which is all right. For the multiplication and division, there are some different operators that we need to use. And those are, if you want to multiply here, for example, if you want to multiply 2 by 3, then what you will have to type in is 2 asterisk 3, and asterisk is basically the multiplication sign in our programming language. So if we run this, we get, of course, 6, because 2 times 3 equals 6. All right, and division is done similarly. Let's try this time to divide 10 by 2. So we're gonna say 10/2, and if we run this, we're gonna get 5, because slash is the division operator. So as you can see, you can do all the operations in all the basic operations that you can do in maths, you can do also in programming. If you want, you can also declare more data. So for example, we can say, okay, well, we want another number, and this time this number is going to be called b. So int b semicolon. Simple as that. And now let's say we want to add 5 to a to get 6, but we want that 6 to be stored somewhere else, not inside of a. So what we can do is simply say, okay, well, b equals what? The value of a, which is 1, plus 5, semicolon. And now, if we print not a but b in here and run this, you will see that b is now 6. But if you want to, you can also print a, and notice that a hasn't changed, and it remained 1. So we have both numbers. We have 1 and 6 in 2 different places in memory, and we can actually access them both without problems. Alright, now that we know that we can use multiple variables and we can do operations with them like in maths, well, let's try and make our program more interactive. To do that, let's try to make our program able to read what we're typing on the keyboard. So if I were to type something like 20 on the keyboard and press enter, somehow the program would retain that number, and we would be able to, I don't know, do some operations like add 2 to it, and we're going to get a result or something like that. So to do this, we're going to have to call a function, and that function goes like this: scanf, parentheses, double quotes, and similar to how printf looks right now, %d, and after the second quote you type in comma, space, ampersand a. So the difference between printf and scanf right now is that you have to use an ampersand behind a. So make sure you do that, otherwise scanf is not going to work. And of course, don't forget the semicolon at the end. And now if you try to run this program, this very simple program, we now get an empty console. Now the program waits for us to type a number in the console. So you can actually just type any number you want. Let's say I'm gonna type 35 and then hit enter, and as you can see, it printed out again 35. So what happened here? First things first, we got to scanf. That guy just retained the number, so waited for us to type in a number, and once we've hit enter, the number was retained inside the variable named a, because we told it to do so. And then it printed a second time 35 because we told it to print a on the third line of code. So I hope that makes sense. So to make our console look at least a little bit better, you can add between the first double quote and the %d here, you can add some text like, let's say you typed the number that, and now if you try to run this, you'll see that we still get a blank console because the program is waiting for us to type a number. So let's type 10. Once we hit enter, you notice that it added you typed the number, and it still pasted in the number that we have typed, the value of A. So you can format your text however you like. Now that you know that, let's try and calculate something with this. So now that we can actually read the number from the keyboard, let's try and add some numbers. Let's say I would like to declare another variable named b, and inside of it I would like to calculate double of a, like how much is 2 times a. To do this, we simply have to first we need to detect where we want to do this operation, right? So we need to do this operation after we read the value of a from the keyboard. So make sure you do this after scanf. And then what you have to write is simply b equals a times, remember this is the multiplication operator, times 2 and semicolon. And let's also print b in here. So we're gonna say, okay, print f, the result of the operation is, and same thing right here, right like above, we're gonna give it %d, and after the double quote, comma, and here we're gonna give it b, because that's where we stored the result. We calculated what a times 2 is, but we stored it in b, right? So a times 2 never modifies the value of a, it just calculates it inside of it, inside the computer itself. Okay, and don't forget the semicolon. And now running the program, still blank screen. So let's say 45. We hit enter, and as you can see here, it says you typed 45. The result of the operation is 90. Now, as you can see, this is correct. We get 90 right here. But one issue I think you can all notice is that these are both on the same line. So that's all a continuous line, which preferably is not really what we want. So to separate lines, all we have to do is simply simulate an enter press, right? So when you typed in Word, for example, if you hit enter, you go to the next line, right? So in order to tell the program that we want there a simulation of an enter, inside the double quotes here, you have to put a special character that looks like this. So it's just \n, and that tells the program to go to the next line. N stands for new line. So if we try and run this, and let's say we want to calculate the double of 38 now, and we hit enter, you will notice that they are now on different lines. So that's how you can format the text even more, and also calculate some numbers based on arbitrary numbers from the keyboard that are inputted by the user. One more thing you can do with the printf function is you can insert 2 variables or even more in the same string at the same line. And what I mean by that is you can have multiple %d basically. Let's try and condense these 2 lines of text into one. So I will just delete this one. I'll say, well, you typed that number. So that's where we're gonna put the number that we typed on the keyboard there. You type that. The result of and I'll say %d times 2 equals, and here's going to be the result. Now note the order in which you add these variables. So the first one after the comma has to be the first, has to correspond to the first %d. So make sure you look here to the left, from the left to the right, and you find the first %d, and you have to ask yourself what do you want to put in here. So in here you want what you typed, so I'm going to say A, and then after that, since we have multiple %ds, you have to add another comma, and after that comma we have to add the second variable, the second value you want to insert. So we already used this, so we go, and we find this %d. And in here, what do we want to add? Well, we want to insert again A, because we want to say the result of, well, if I type in 5, I'm going to say 5 times 2 equals that. So again, I'm going to insert A once again, and then comma, because we have a third %d, and since this is the last and this is the result, here is where we're going to insert the result. So here we're going to say B. Okay, so this is how it works. Let me just draw a little bit in here, and maybe you'll, oops, not that, this. Alright, so see, this %d corresponds to this A, right? And then this %d corresponds to this A, and this %d corresponds to this B. Alright, so that's how they are going to be inserted inside our text. Okay, now let me see if I can clear this. Alright, so now if we try to execute, and we're going to say, well, let's say 7, you'll notice that it says you typed 7, the result of 7 times 2 is equals 14. Alright, so as you noticed, we inserted A twice in our line of text, and we inserted the result at the end. So keep this in mind. You can do this for however many variables, however many %ds inside a single line of text. Okay, so let's say I want the following algorithm. I want an algorithm that calculates the sum of two numbers that were typed by the user, and also it gives the product of those two numbers, the same two numbers. So let's figure out how we should tackle this problem. First things first, let's review what I said. I said two numbers, right? So the first and most important thing is that we need two places in memory, in order to be able to store this. In effect, we need two variables. So we're going to start with int A, and the next time we can type in int B. We know we're going to have to use them. Next up, we need two numbers that are typed by the user. So we need to take the input from the user. So to do this, we can simply use the scanf function. So scanf parentheses double quotes %d, and we want to store the first value into A, right? I hope this already makes sense to you. And well, I want to this time read two numbers, so nobody stops me from actually reading two numbers. All I have to do is just type this thing again. So scanf parentheses double quotes %d comma space ampersand, and here we type in B, because that's where we want to store the second number. We don't want to store it in A again, because that would overwrite it. Okay, now that we have the two numbers, let's try to print the sum of those two numbers. To do this, we will have to declare another variable in which to store that sum. So let's say right here, int sum, let's call this sum, semicolon, and in here we're going to calculate sum equals a plus b, semicolon. Okay. All right, now let's try and print this sum, right? We want to see this in our program. To do this, we just use the printf function as we've learned before. So printf, parentheses, double quotes, let's say the sum of the numbers is, and %d for a number, and we give it the sum, of course. We don't give it a nor b, we give it the sum, semicolon, and then let's try and run this. Okay, so we're already printing something. It should at least show something up on the screen. So F11, run this, wait a little bit to compile. Okay, blank screen, because, well, remember the program executes line by line, so it went past this, oh sorry, it went past this, but it stopped here. Here's where it's waiting for us to type in a number and hit enter. So let's type in, I don't know, like 12. Hit enter. Okay, we hit enter, and now it's here. Now the program is actually stuck here on this scanf, and it's saying, all right, well, you gave me one number, but you typed in here two scanfs, so it's waiting for us to type two numbers and hit enter twice, basically. So let's type in 4, for example, and let's hit enter. So as you can see, the sum of the numbers is 16. That's great. That's absolutely amazing. Okay, well, let's try and calculate the product of it. Let's see how we can do this as well. So the simplest way is just let's declare another variable here, as we did up top. Let's say product, semicolon, and then the next line product equals a times b, right? Because asterisk is the multiplication sign in C, and then semicolon, right? The same as we did here, except now it's named product and it's a times b, not a plus b. Hope that makes sense. And just to show that we've calculated the proper product, let's also print it on the screen. So printf, the product of the numbers is %d, and we just type in here product, of course. Okay, well, as you can see, I just basically replaced sum with product from the above, and used, instead of the plus sign, the asterisk sign. So let's try and run this. Again, it's waiting for us to give it two numbers. Let's try this time, I don't know, 7 and 5. And as you can see, the sum of the numbers is 12, and the product of the numbers is 35. Again, you will notice that we have both results on the same line, which is usually undesirable. Alright, so to fix this, you've learned in the past that all you have to do is just type in right here \n. That's a special character, simulates enter. Simple enough. If we hit an F11 and we give it two numbers again, let's say 2 and 6, as you can see, it will give us the sum and the product of the numbers. Amazing. Now, in next videos, I'm gonna try to optimize this program for it to look better and run better. Okay, so we can see that our algorithm works. So if we run this and we give it a few numbers like 5 and 2, it gives us the sum and the product, so it's correct. We don't have any issues there. But even though the program is functioning, it doesn't mean that it's at its best state. So you always have to take into consideration the design of the code, and by that I mean, what if somebody else comes in my place, for example, and just sees this code and is like, okay, well, what does this code do? Can he understand what this code does through the way you code it, through the way you structured your code? Maybe, maybe not. We're gonna see in this segment how we can actually improve this. So One thing I want to go over really fast is these two parts. So instead of doing int sum and then assigning a value to that sum variable, we can simply delete this line altogether, like so, and can say a plus b equals a plus b, and that's the equivalent of what we had before. We had a declaration and then an operation on that sum, and now we have them both crammed together. All right, and you will notice that we can do the same thing down here. So just delete the line and add equals to a times b. Okay, let's save, let's run, and let's give it a few numbers, and as you can see, it's exactly the same thing. All right, great, that's already better. We've removed 2 lines of code through this. That's great. All right, one more thing let's try now is, well, I have here int a and int b. Can't I do the same? Can't I declare these two like both at the same time? Because I'm actually declaring them one after the other, so it doesn't matter which order. I just want both of them to be there at the same time. So, well, I could just basically cram them together like that. I wouldn't do much, right? That wouldn't help too much. But there's an even faster way of doing it. Instead of saying int a semicolon int b, you can say int a comma b semicolon, and that declares both a and b as an integer type. All right, so if we try to run this again, it runs, and it's running as usual, right? So those two are equivalent. Okay, well, you would notice that one more thing, or the same thing we can do down here with those two variables. Well, because we're actually doing an operation that uses a and b after we read the numbers, we kind of have to leave them here. We cannot add them. We cannot add the sum up top because, well, it's going to calculate the numbers of what. So if I copy and paste this right here, it won't calculate what I want. Right? Let's try this. So if I give it 2 and 6, well, 2 plus 6 is definitely not 24. So that's definitely not correct. So as you can see, if I do it here, since the program is executed line by line, it's going to take the values of a and b at this time in the execution process. And a and b can be literally anything, since we didn't assign it any values. All right, so, okay, well, let's take this out and put it back here, because that's where we want it to be. Let's delete the comma. But one thing we can do, though, is move this variable near the sum. So we can just cut and add a comma here and just paste it here. And like so, we have already removed another line of code, and another one from here, since we've merged those two. If we run this and say, I don't know, 4 and 6, it gives the correct answer. So hope that makes it a little bit clear on how you can actually optimize our code. So now it just looks much better to the eye compared to what we had before, which was this thing, right? As you can see, we had basically 11 lines of code, well, 10 lines of code minus this return 0, and now we only have 6, right? So the fewer lines of code, the more readable the code is, usually. Okay, keep that in mind. Keep trying to compress the code as much as possible. All right, let's see what are comments and how can we use them in our programs. Now, comments are simply a message to the person reading the code. Okay, comments are not something that is used inside our algorithm. It doesn't calculate anything, it doesn't change anything, it doesn't declare any more data. It's just a simple message telling the programmer what this part of the program does, or where does it use its variables, or stuff and stuff. Very just a simple message. It can be anything like hi. Alright, so how can you actually add a comment? It's very simple. We can say, we can add one right here. We can say, so it starts with a double slash, and anything after the double slash is a comment. So that means that it's ignored by our program, basically. We can write anything we want here, right? Anything we want here, right? We can write that, and if we run this, it's not gonna complain. It's gonna work the same as before, no problem. All right, but how are they used? Like, what can we do with them? I know we can, yeah, we can write messages, but why write them? Well, in these programs, I cannot really exemplify why we need them, but in larger programs, imagine that this was like a really small part of a really huge code base, thousands of lines of code or something like that, and tens of folders and files. Yeah, that could be quite problematic to understand. And we as programmers cannot really comprehend everything that is in there. It's really difficult. So we have comments that just gives us a summary of what that piece of code does. All right, enough talk. Let's try and comment this code right here. So we can say here at the beginning, here we declare the variables we use. All right, and then we can say below it, we can say here we read those variables. Then down lower we can say here we calculate the sum and the product, and then here we print them. Simple enough, right? It just tells us a message. We can even leave a space. I usually like to leave a space above each comment just so that it's more clear, since it basically defines a part of your code. Okay. Now, as you can notice, it's much cleaner, it's much easier to read it now. You know that, oh, here goes all the variables that you want to use. Cool. Here we just read some stuff. Simple enough to understand, right? Then we do a sum and a product. Again, very simple. And we print. Still not really a huge problem. Whereas before, when we had this code, it was kind of difficult to really understand. Yeah, sure, we're still calculating the sum here, but for example, we were doing A and B scanf, that's the same way, but here we were doing the sum, then printing it, then doing the product and printing it, right? Now it's much simpler. Now we have a part of the code that only prints for us and doesn't do anything else. Hope that's clear. Hope you can understand why you want to use comments. Oh, and one more thing. On how you can actually use these comments. If you put them on the same line with some line of code, if you put them after, everything after the double slash is going to be ignored. So if we put a comment here and say this is a comment, everything only after this double slash, these double slashes, is going to be ignored. This part is not going to be ignored, of course. And one more type of comment is a multi-line comment, which you can do by using the /* and you can end it. So this is the beginning of the multi-line comment, and then * to end the multi-line comment, and then everything in between here is going to be considered a comment. So this would be a comment, and this also would be a comment. I hope that's clear. In case you need to explain this in many lines of text, this also comes in handy. Okay, so I have this piece of code and it's reading a number and it's printing something. It's printing, what does it say? It says the predecessor of the number is. So what we want is, we want to store the predecessor of the number we typed in the variable named a. So to do this, it's a bit counterintuitive, but let's try. Okay, what we have to do is very simple. All I have to do is say, well, where do we want to store it? Since here we have a, we want to store it in a, so we want to assign a value to a. So again, assign keyword, so that means equals. Next up, we want to find the predecessor of a. What's the value of the predecessor of a? Well, we know that the predecessor is just a minus 1. So a should be equal to what? A minus 1. Simple as that. And semicolon. So I know it might be counterintuitive because in maths this is a comparison, it's always going to be false, but in programming equals is an assignment, and it just says, okay, well, assign to the value of a the previous value of a minus 1. Let's see what happens. So if I run this and type in 90, for example, hit enter, you will see that the predecessor of the number is 89. Okay, so it's a little bit counterintuitive, but I hope you understand what happened there. Alright, now let's learn about the shorthand operators. So instead of doing a equals a minus 1, we can also simply do a minus equals 1. That is exactly equivalent with what we just did before. So a minus equal 1 is the same as saying a equals a minus 1. It's just a convenience or a convenient way to find the predecessor of a number. So if we try to run this, you will see that it does exactly the same thing. Alright, now one more version of this. If you want to subtract 1 from the number, you can also use the even shorter hand of this operator, the minus minus operator. So instead of saying minus equals 1, you just say a minus minus. And that says, well, okay, take the value of a and assign to it a minus 1, right? So just decrement the value of a. All those three versions of it are equivalent, so don't forget that. If we run this, of course, we get 5. Cool. Now you can do the same with addition. If I wanted to say print the successor of the number, then I would say, okay, well, a plus plus, right? Instead of a minus minus, you just say a plus plus. And then if we run this and say, let's say 6, you will notice that now a has the value 7. Okay, and of course same thing applies if we do plus equals 1. I'm just going to demonstrate that real fast. There we go. And a equals a plus 1. So those three are also equivalent. There's also shorthands for the multiplication and the division operator. You don't have a, well, you have a star equals, you can say here, for example, 2. That would give us the double of the number. So let's try, let's try and run this. If we give it 4, we got 8. So that also is equivalent to a equals 8 times 2. There you go, exactly the same thing. And of course it applies for division, so it can do a equals a slash 2. If we run this and say 6, I think I forgot to change the text, but that's actually the half of the number, which is 3, and you can just replace that with a slash equals, and you do F11, and if you give it 4, you get 2. Okay, so I hope that's clear. It's just a very fast way of typing some constructs, in case you need it. Here's an interesting concept. What if we want to print something on the screen when a condition is true and print something else if that condition is false. Well, let's see in this example here. Here we're reading from the keyboard into the variable a, and then we're asking the question, is this number negative? And well, it's up to us to find out. It's up to our program to make it find out. Right, so to do this, we're gonna use what are called if statements. So an if statement looks something like this. If space parentheses, here goes the condition of this if. In our case, we want to find out if the number is negative. So let's say, well, we need to compare it with something. So to do this, we can simply do a less than 0. If a is less than 0, then inside brackets, the program is going to do something, right? So if a is less than 0, then let's say it's going to print, yes, the number is, or %d is negative. And I'm gonna give it the number here, just so that it looks nice. And let's try and run this. And let's try and give it a negative number, like -10, and it's going to say, is this number negative? Yes, the -10 is negative. Good job, my English, but yeah, you get the point. If I try to insert a number like 3, it's not going to print anything, as you noticed. So if the condition is false, nothing's going to happen, because it's that's how the if statement works. But if you want something to happen when the condition is false, you will have to just add the else statement to this if statement. So if and else go hand in hand, okay? And this is how it goes. After the closing brackets of the if statement, you have to add an else here and another set of brackets in which you put whatever happens if this statement is false, right? So if a is not equal or is not less than 0, what do we do? Well, let's try and print, and then say, no, the %d is positive. I'm going to give it a. And let's also correct this. Okay, so if you try to run this, let's give it a number like 7, and as you can see, it says no, 7 is positive, and you will notice that it didn't print anything from here. It didn't say yes, the number is negative. So if it checks the condition, if it's true, it goes here and executes the code inside the brackets. If it's not, it's going to execute the code inside the second set of brackets in the else statement, if it has one. If it doesn't, it's just gonna jump forward and go to the next line, which is this one for us. I hope that's clear enough. Alright, so you will notice that I used a peculiar character inside the if condition. That character is an operator, is a comparison operator, and it compares a with 0, and it checks if a is, in this case, less than 0. We can also use the higher than 0 operator. We can use the higher or equal than 0. So if a is equal to 0, this will also return true. We can use less or equal than 0. We can use equal to 0 or different than 0. You'll notice that I use double equals. That's not a typo. That's actually inside the programming language. It was defined like so. The double equal sign is actually a comparison between a and 0. If you only type a equals 0, that's an assignment. That basically says, okay, give to a the value 0. And yeah, as a condition that doesn't work, right? You have to compare two things. And to do this, we just say, okay, well, double equal. right? That's how the creator of C solved this issue. We have double equals, and now it's checking against a if it's actually equal to 0. If it is, then we go inside the if If it isn't, we just ignore or we go to the else statement. Alright, so let me list them again. These are all the operators. You have less than, higher than, less or equal, higher or equal, equal or not equal. These are the conditional operators and we can use them. For example, let's say we want to print if, I don't know, if this number is not null. So we can say, okay, well, is not null or not neutral, I guess. I think it's in math it's neutral. And to do this, we simply say if a is not equal to 0, because 0 is the only neutral number, then we print yes, a is not neutral. So we try to print this, and if we give it 3, it's going to say yes, 3 is not neutral. And if we run it again with 0, hit enter, nothing is printed on the screen because we don't have an else statement. But I hope that's clear. We have only a few conditional operators and they are very simple to understand. Okay, so let's say we want to find out whether the number that we type on our keyboard is between two other numbers. It's between 0 and, let's say, 4, inclusive. To do this, we're going to have to use if statement. You might have noticed that. So the first thing we have to check is if it's less than 0. If it's less than 0, that it's clear that our number is not in between 0 and 4 inclusive. So if a is less than 0, we can also add spaces to make it more clear, by the way. In case you don't like them, you can leave it like that. I prefer this condition. So if a is less than 0, then let's say the number is not, or no, %d is not between 0 and 4. Simple as that. Okay, so if it's less than 0, we're printing that. But what if it's not? If it's not, that means that it's either 0 or it's a positive number. Okay, so we're gonna have to go through the else statement, and here we're gonna have to do something interesting. We're gonna have to check again if our number is what? Higher than 4, right? So if our number a is higher than 4, then it certainly is not in between 0 and 4, right? If it's higher, then it means it's 5, 6, 7, and so on. So then we print, well, exactly the same thing, I guess, because this means that it's not between those two parameters. But if it's not, guess what this means? Think about it for a second, maybe even pause the video. This means that the number is, well, it's positive or 0, since we're already on this else statement, right? So we went past this condition and we know that this condition is false. So a can't be -5 or -3. It's either 0 or a positive number. And if we go in this conditions else statement, if we say here else, and it also means that it's not higher than 4, right? So it's a positive number or 0 that's not higher than 4. That means that it's a positive number or 0 that is less or equal to 4. So this means that it actually it's actually between 0 and 4, right? It's actually in our interval. So we can printf right in here. We can say d is between 0 and 4 and give a here. Okay. And if we try to run this, we can say, okay, well, for 5 is going to say 5 is not between 0 and 4. That's correct. And if we give it, I don't know, let's say 2, it's going to say that 2 is between 0 and 4. So take a moment to understand this code. One thing that I wanted to exemplify in here is that you can use if statements inside if statements, right? So you can use as many statements inside statements you want. So you can even add another one here, and in that one you can add another one here, and so on. So you can go on forever with this, as long as the structure is correct, as long as you don't have any typos, basically. So one more operator that I haven't talked about in this tutorial is called the modulo operator, or the mod operator, or the remainder operator. What it does is simply taking two integers, divides them, and it returns the remainder of that division. Not the quotient, but the remainder of that division. So we can, let's try using it. So let's declare a number right in here, and let's try, let's first print out a message and read this number, okay? That'd be the easiest way to do this. So %d at a, and we're going to print, let's say int r from remainder is going to be equal to a, and the operator is noted like so with a %, and then you give it also a number that you want to divide by. So in this case, let's say we want to get the quotient, not a quotient, the remainder of the division with 4, for example, and semicolon, and let's print out this. The remainder is, well, r. If we run this, well, let's try, for example, 12, right? Is going to give us 0, because 12 divided by 4 is 3, and remainder is 0, because it returns a whole number. If I give it, for example, 11, this returns 3, because 11 divided by 4 is 2, and 11 minus 4 times 2 is 3. That's the remainder. Alright, I hope that's clear. You can actually change this number to anything. In fact, this operator is most used when checking if a number is odd or even. So what we can do here is actually say, instead of 4, let's try 2. And let's see what happens if I try to print out the remainder of the division with 2. So let's give this the number 5. We're gonna get 1. Okay, let's try again. Let's give it the number 9. We get also 1. Let's try this time, I don't know, 4. 4 gives us 0. Interesting. And if I give it 12, 12 also gives us 0. What does this mean? Well, this basically means that we can check through this remainder operator whether or not our number is odd or even. So how can we do this? Well, let's try and add some code in here. We can add an if statement, and inside this if statement we can say if r equals to 0. So remember, this double equal means actually comparison between that and 0. Excuse me. Brackets, and in here we can print out, well, guess what? If you divide a number by 2 and the result or the remainder is 0, that means that the number is even. So we can just type in the number is even. Let's also add a new line in here so that it prints out perfectly. Else, well, the only other result would be 1, because if you divide any number by 2, you either get a remainder of 0 or a remainder of 1. You cannot get a remainder of 2 or 3, or, you know, doesn't work like that. So you can just print out that the number is odd. If we try to run this, and let's try 12, for example, the remainder is 0 and the number is even. So we did detect that our number is even. If we try to run this again for, I don't know, for 5, it will say that the number is odd because the remainder was 1. Okay, so I hope that's clear. You can use this remainder in many ways, but the most used way is just to find whether or not the number is odd or even. And you don't have to store the result like I did here. Most people would just remove this and copy and paste it here, right? And it would just, they would just check it like so. So you just modulo 2, and we're gonna compare the result with 2. With 0, sorry. So it's gonna work in the same way. If I try, I don't know, 101, it will say that the number is odd. So keep this in mind. So what are loops and how can we use them? Let's find out. Let's say we have this program, which all it does is just prints a line of text in here. And if I run this, of course, we only get a line of text. What if I want to print this line of text on the console, well, 5 times, let's say? Well, simple enough, right? I just kind of select it, Control C, and then Control V, like 5 times. Fair enough, right? Simple. If I run this, we're gonna get that 5 times. That's easy. Cool. Now what if I want this 10 times? Well, I can copy and paste this, right? So let's do that. And maybe do that. And let's run this, and of course, is it 10 times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, this works. The only issue is that, what if I want an arbitrary number of times? What if I want that to be the number of lines that are printed on the screen are determined by the user. So when I type in on the keyboard 9 and hit enter, it's gonna print in the console 9 times this line. How can you do this? How can we accomplish this? Well, let's take a look at loops and see how they work. So first, we're going to take a loop at the while loop. The while loop has this structure. Simply type while, in parentheses, here's a condition, and the condition is similar to what you had in an if condition. It's actually the same thing. It's a condition that returns a value of truth, right? It's either true or false. Okay, and then brackets, and inside the brackets is the code. Now let's try and insert a valid condition here. First, I'm gonna tell you exactly how this works. Okay, so we have, let's say, int I equals 4, and let's say I is higher than 0. Alright, simple enough. The while loop, simply what it does is, first, like an if loop, it checks the condition, right? It says, alright, is I higher than 0? Yes, it is. I is 4. Then it executes the code inside. Now, the difference comes when we finish executing the code. When we finish executing the code, the while loop rechecks the condition. So it checks again, is I higher than 0? Well, it is. We didn't really modify it, so it's still 4, right? And it executes again. And it checks again. And it executes again. And so on, while this condition is true. I hope this makes sense, right? Now, due to how we structure this while, if we try and print here that line of text, which I think I have here, just like so, let's see what happens, okay? So if I run this, you're going to notice that the program just runs forever and ever and ever and ever. It never stops, right? So let's kill this, because it's just kind of obnoxious. And let's find out what's the issue. The issue simply is that this condition never changes inside this code, right? For a while to actually finish, the condition has to be false at one point, either at the beginning of the execution or somewhere inside the code we have to modify the value of truth of that condition. And how do we modify it here? Well, it's quite simple. We just have to modify the value I, right? So all I can do here, for example, is, let's say after we print the line, we can modify I. Let's say I equals -1. Okay, we're gonna make I not higher than 0. Let's see what happens if I execute it like this. F11, run, and you're gonna notice the text was printed only once. Now let's see what happened here. We have I which is equal to 4, and then the while loop checks if I is higher than 0. I is higher than 0 because it's 4 is higher than 0. Then it executes the code. It prints the line, and then we assign to I the value -1. Okay, and what did I say it happens after we stop executing the code, we finish executing the code inside the brackets? The condition gets rechecked. So after this, we go back here to the condition and we say, all right, well, is I higher than 0? Well, no, because we've assigned it to -1. So -1 is not higher than 0. And we get out. That's how this program runs. To make this program run properly, well, we don't want it to just execute once, right? We might want it to execute a couple times. Well, to do this, how about instead of actually assigning to I the value -1 every single time we run the while loop, let's try decrementing it. You remember that shorthand operator? Yeah, we can use that. So you can use, instead of saying I equals -1, let's say I minus minus. What that does, it basically subtracts 1 from the current I, and it saves it inside the variable I. Okay? Let's see what happens now. What do we get? Think about it for a second. Try to go through the code in your mind, or even try coding it yourself to see what happens. So, running it reveals that we now get 4 lines of code printed, or lines of text actually, not code. Well, why is that actually? The answer is pretty simple. We have here I equals 4. The condition we know is true, and then we print, right? Printing, and then we are decrementing I. So saying, okay, I equals 4 minus 1, because I was 4, and we just decremented by 1. Now I is 3. So we check the condition again. Remember, we printed once, and the condition is still true. 3 is higher than 0. So the code re-executes, right? We print again, a second time, and then I becomes 3 minus 1. All right, so that's 2. So now I is 2, and then we go, 2 is higher than 0, that's true. We print again, that's a third time. We make I equals 2 minus 1, which is 1. We check again, 1 is higher than 0, that's true. We run again, we print our text, then we get to this line where it says I equals 1 minus 1, which is 0, so it makes I equal to 0. Okay, well now after we've executed this line, we check the condition and say, okay, well, is 0 higher than 0? Well, that's false, right? Because it's strictly higher. It's not higher or equal, so yeah, that's false. So it just stops and returns 0. That's what happens, and that's why we are getting 4 lines of text printed on the screen. Hope that makes sense. So I did say in the beginning that we wanted an arbitrary number of lines of text printed on the console. To do this, we simply have to somehow replace that 4 with something we print, something we type on the keyboard. How do we do this? Well, you remember our old friend scanf, right? All we have to do is first let's remove this assignment, and after we declare I, let's just say scanf %d and %a and semicolon. And now we can print this line of text an arbitrary number of times. Alright, so let's try this again. So now it's waiting for us to type something on the console. So let's say, I did say 10 times, right? In the beginning we printed 10 times this line of text. So let's try that. Let's try 10. If I hit enter, is that 10? 3, 4, 5, 6, 7, 8, 9, 10. Right. So that's how you print something, or you do something an arbitrary number of times inside the computer. So let's go back to this example. So in the previous videos we've used the while loop. Let's try using the for loop this time for the same purpose. So the for loop goes like this: for parentheses, and inside parentheses it has 3 parts. Alright, I'm going to go through all of them. First is the assignment, second is the condition, and third is the increment or decrement. So before this, let's first declare a variable, for example I. Okay, we're going to need that. And then inside the parentheses we're going to use this variable to do the operations on, like we used previously. So we first have the assignment. So the assignment says, all right, well, this thing is executed only once. We're assigning a value to this variable. All right, well, let's say we're assigning to I, since we're going to use I, the value 4, like we did previously, but this time we're going to do it in the for loop. All right, next part of this for structure, semicolon after it. That's the condition. The next one is the condition, and here we can actually use the same condition as in the while loop. The for loop in some sense is basically the same as the while loop, so you can use it like so. So what was the previous condition that we used? Well, I is higher than 0. Simple enough. And then the last part, semicolon, and inside here we can do either decrementing or incrementing by some number our variable, right? So what did we do before with the while loop? At the end of the while loop, at the end of the code that was inside the brackets, we did I minus minus. Well, let's try and do the same thing here, okay? So let's try and decrement our I by 1 every time we run the algorithm. So I minus minus, and then inside it, and then open and close brackets. And inside the brackets we again copy and paste this code. Cool. Let's try and run this. So F11, and you will notice that we've printed this line of text 4 times, right? How is that? How did that just pan out? Well, to understand this, let's see exactly what happened. Let's go just line by line. Okay, so we first not initialize, declare I, and then we go inside this for loop. The 3 parts are executed like so. The first part is only executed once, this one, right? So first, and it's executed at the beginning. So the first thing we do is assign 4 to I, right? So now I has the value 4. Cool. Next up, the condition is verified. So we're checking if I is higher than 0, which incidentally it is. 4 is higher than 0. It's all right. All right. After the condition is checked, like in the while loop, we're executing what is inside the brackets. And what is inside the brackets? Well, this printf. So we're printing it once, and it goes back to the for loop. But this time it doesn't immediately check the condition. What it does firstly is actually decrement I, or do whatever it is in this last part of the for loop. Okay, once it decrements I from 4 to 3, it checks again the condition. Is 3 higher than 0? Yes, it is. So it does this again, it decrements it again, then it assigns I the value of 2, and then it checks the condition, it prints again, then it decrements again, we get to 1, prints, checks the condition, prints, decrement, and then check the condition. I hope that's kind of clear. Alright, so now that we know a little bit about C and how it works, let's try creating a simple program that does something relatively useful. So this program, I want to simply type on the keyboard a number, let's say, 4, and I want this program to output on the screen another number, and that number would be equal to 1 plus 2 plus 3 until this given number 4. So in this case it would be 1 plus 2 plus 3 and plus 4, that would be 10. So I want, whenever I give it 4, it should output 10. Alright, if I give it 5, I just add in 5 here and it's going to be 15, the output. Alright, so with that in mind, let's see how we can actually create this program. So first you have to think about what data you have to use, like where do you store your data and how should you call them. So first we need a place to store that input, right? We type that number and that number has to be stored somewhere. Well, let's call that number n. Another thing we need is the output as well. We need to store somewhere the sum. Well, the sum. So let's call it the sum, I guess. It's the sum of all the numbers up until n. Okay? And one more thing we'll need for this program is a loop. Okay, so whenever we used loops, we used an integer called I. So let's keep that the same. Okay, now we have the numbers. Let's simply print a message here. Let's try and read first the input. So we're gonna print a message. Just type a number. Okay. And then we're gonna scanf, if you remember correctly. You give it a certain string here and a certain special character called %d, and the second parameter after comma, you give it a number in which to store that the number you type. So we said that n is our input, so we want to read inside n. And don't forget the ampersand. Alright, so now we are reading this number. Let's think about what we need to do next. Well, we need to do 1 plus 2 plus 3 plus 4. As I said, we need a loop, right? We need a loop that goes through and executes for 1, and then for 2, and then for 3, until it gets to n, and then it exits. Okay, well, simple enough. We can use any of the loops that we've talked about. We can use the while loop or the for loop. I'm gonna use the for loop. It's simple and straightforward. So let's start with 4. Where do we start with? Well, we're gonna sum each number. So we can start at 0 because any number plus 0 is still that same number, so it doesn't affect the result. And that means that it doesn't matter if you start at 0 or at 1. Just to make it a little bit more efficient, let's start at 1. And till when do we want to exit? Well, if we have 4, right, as our input, we want to add 1, we want to add 2, we want to add 3, and we want to add 4. So once I gets to 5, we want to exit, right? That means that the condition should hold true up until 4, right? Which means that we have to check I if it's less or equal than n, right? So we go up until n inclusive. So if I type in 4, I want 4 to be added as well. All right, and we get we're gonna increment I this time. We're not gonna decrement as we did in the past. So just I++. Okay, and in brackets, in here, what do we do? Well, we have this sum variable right here, but we want some way to add to it, right? We don't know what value right now it has. It has a random value because we initialize it like so. So we need to give it a value beforehand. So let's go here before we start the for loop and just initialize this sum with, well, a neutral value, like, well, 0. Okay, now that we've initialized the sum, we can start adding numbers to it. So how do we do this? It's simple. We want sum equals to the previous sum plus, well, the current number, I. Okay, and semicolon. And this program is going to execute, well, n times, since it's going to start from 1 and it's going to exit after the nth iteration. Okay, we can also use the shorthand version in here if you want. So you can go ahead and type in plus equals. I'm gonna leave it like this. And one more thing we want to do is actually print on the screen our sum. So let's say in here printf the sum is, I'm gonna say %d, and after it just give it the sum. Alright, if you remember correctly, %d says, alright, go look after the comma and get the value of that variable that you're passing here and plop it in that string that you're trying to print on the screen. So that's a special, those are special characters. Okay, let's try. Hit F11, compile and run. Okay, so type a number. Well, let's type 4 as we did before. Let's hit enter and we're going to see that the sum is 10. Alright, fair enough. Let's test it a little bit more and see if it actually works for some other numbers. Let's say 6. 6 should be, what should 6 be? Well, 1 plus 2 plus 3 plus 4 is 10, plus 5 is 15, and plus 6 is 21. So let's see if it gives us 21, which it does, incidentally. Alright. So that's how you can use the loops for simple programs that are somewhat useful. That's how loops can be very useful. Let's see how this for loop runs, right? Because I didn't really explain this and it's a little bit complicated at first, right? If I draw here, I'm going to draw here a table. Okay, I'm going to say I want sum, so sum right there, and the second column is going to be I, and then each row is going to represent an iteration of the for loop. Alright, so, well, we know that the sum is 0 in the beginning, right? So I'm going to just add the row here 0, and we know that we are initializing I with 1 first. Okay, so the first iteration, I is equal to 1. Okay, and sum is equal to sum plus I. Well, what are the values of sum? Sum is 0 and I is 1. So sum is going to be 1. Cool. Okay, next iteration. Next iteration, because of I++, we're getting I to be equal to 2. And then we're going to calculate the sum of those two. So sum equals the previous sum, which is 1 plus 2, which is going to be 3 right in here. Okay, next iteration, again incrementing I, and then in here sum equals the previous plus I, so that would be 6, and then is 3 less or equal than n? I didn't mention that n is gonna be, well, 4 for this example. So, well, no, 3 is still less or equal than 4. Okay, so we increment. And then we check. Is 4 less or equal than 4? Well, yes, it is actually equal to 4, so it's okay. We're executing this time. So you say, alright, sum equals the previous plus the current I, which is 10. Alright, and now I gets to be equal to 5, right? Because after the code here is executed, we get to the increment, and then we check the condition. Is 5 less or equal than 4? Well, no, 5 is actually higher than 4. So we exit, and we print out the current value of sum right here, which is incidentally this value. One more thing I want to do before going forward is show you how you can convert a for loop into a while loop and vice versa. So here we have a for loop, but I did say that we can use a while loop if we wanted, and here's how you would do it. Alright, so first you will have to take out the assignment. Let's cut and paste it at the beginning. Okay. Next up, we're gonna cut and paste the increment at the end of the for loop inside the code. So inside the code, not after it. And then we remove the semicolon, and we simply replace the word for with the word while. And this will work exactly the same as a for loop. We can test it out by compiling and running, and let's give it 5, we get 15, which is correct. Alright, so we have this program in here. Let's go step by step and see what this program does. So first thing that it does is declare some variables. It declares A, B, and the result. Then it prints out some text, and it reads a number, and it saves it inside A. And it prints out some more text, reads a number, and stores it in B. And then we give result the value of the division between A and B, the two numbers that we read, and then we print out that result. Okay, so at first glance, this program simply divides two numbers that we type on the keyboard. Okay, well, let's try and run and see if that's correct. So if I'm gonna try to divide, I don't know, 9 by 3, it's gonna give us 3, and let's test it one more time and see if I divide, let's say, 15 by 3, we get 5. Okay, that's amazing. Now, there might be an issue if we try to divide certain numbers. Alright, let's try to divide this time 7 by 4. Well, that's a problem. We got 1. But if I check my calculator and I try to divide 7 by 4, that result is not quite correct. We get, yeah, the number before the decimal point is 1, but after it there's some more stuff there. There's 75, so the result is 1.75. We only get 1. How can I make this program output everything after the dot? Let's see. So the first thing we have to keep in mind is that we are using int, right? We've always used int so far. And what is an int? An int is a variable that can store whole numbers, right? So in here we can only store whole numbers. In the result, inside B, inside A. So after we read the numbers, we're storing the result. We're saying, okay, result equals a over b. But what if a is 7 and b is 4? Well, we get 7 over 4, but since the result can't hold anything but whole numbers, well, the result gets rounded down, right? So it gets rounded down, not up, down, to a whole number. Okay, so how can we solve this? Well, there are a couple things that we have to do before making this program work with decimal points instead of numbers. So first thing we have to do is change the result. So change the result to a different type, and that type is called float. And float comes from a floating point number. A floating point number is basically in computer science is simply a variable that can hold a decimal place, and it can hold a simple fraction. Okay, so now that we have result as a float, well, let's see what happens if I try to run this right now, and if I give it the same number, so 7 and 4, well, this time we're getting 0. That's not that great, is it? No, I don't think so. So that's worse than before. Before we were getting at least a round down of our result, right? It was 1.75, we got 1. This time we're getting 0. Why is that? Now this 0 has to do with the way we're printing to the console. Since we've always used ints in our tutorials, we've always only printed ints. And we've always used this %d, this special character for printing integers. But this time we're gonna have to print a floating point number, and for that we have to use another special character, and that special character is %f this time. Okay, so we changed that. Let's see what this program does now. I'm gonna give it the same numbers, so 7 and 4, and look at that. Well, we got the quantity is 1.00000. That's not the greatest answer, but at least we got a decimal point this time. We still got a round down of our result, and we have to figure out what happened there. So let's see what else we're doing wrong. Well, the issue is not here, not here, not here, it's basically here. Okay, and the issue comes with how C calculates division for certain types. Alright, and what I mean by that is, well, if C tries to divide two integers, right, be them 7, 4, or 10 by 2, or 15 by 3, it doesn't matter. If C divides two integers, two integer types, it's going to always return an integer. It's always going to round down that result. That's how C works. It's a little bit problematic, but it does round down whenever you divide two integers. So what do we have to do? Well, the best thing to do is to change the type of the variables we divide, because if we would divide two floats, we would get a floating point number as a result, and that would be the correct answer. So let's try and change the types of A and B right here. So I'm gonna go here and replace int with float, and if you notice, we're still using %d here, and that is not correct. We have to use the same way that we print a float, we have to read a float. So we're gonna have to be %f, because this time A is a float, and same thing with B. And now let's run our program, and if I give this program the same numbers, we're gonna notice that we get 1.75000000, which is the correct answer. Alright, so another data type that I want to talk about in here is called an array. An array is simply a set of certain of one or more variables. So think of it as just declaring or using more variables at the same time. I think if I give you an example, it's going to be much easier to actually understand this concept. So I can declare an array by simply saying int a, but after a I simply have to add two straight brackets, and in between I have to give a number that represents how many variables we are declaring, right? So all the variables in this array are going to be of type int, and we're going to have, well, how many? Let's say 5 in here. Okay, and how can we use this? How can we use this array? Well, let's say we want to store some numbers inside the array. Simple. To do this, we simply have to do, we cannot just do a equals 10, okay? So a now is an array, so we cannot assign it a number because it's, well, multiple places in which we can put numbers. So we have to give it a, like, we have to say, okay, well, which number you want to assign to. So we can say a of, well, let's say 0, right? That would be the first number in our array, okay? And our array has 5 elements. So let's try and give numbers to each one of them. So let's say a of 1 would be 12, a of 2 equals 15, a of 3 equals 20, and a of 4 equals 4. As you will notice, there is no a of 5 as we had up top, right? There's no a of 5. So never ever try to assign or read a of 5 when you have an array of actually 5 numbers. So the indexes go from 0 to 4 inclusive. Okay, so, well, we did assign some numbers to it, and we can also try to, well, read from that array by simply saying, okay, well, the second number in the array is, and you can simply give the printf function a of, well, which one would be the second? Well, a of 1, because a of 0 is the first. That would be the second number in the array. And you will notice that if I launch this, the second number in the array is 12. So it's the same way, it's just you have to add this straight bracket notation after the name of the array. Okay? So let's try doing something more interesting with this. Let's try using loops. Okay? Let's try getting the sum of all numbers inside the array using a loop. To do this, well, since we already have the array, we need to simply define or declare a variable to store the sum. So I'm gonna say int sum, and we're gonna instantiate with the number 0, and for the for loop, we're gonna also need to have another variable with which we can iterate over the array. So we're gonna say int I, and here's the for loop. We'll start from, well, let's think about where do we start this loop. So we want to go through the whole array. Alright, so make sure in here you start from 0, so I should start from 0 and go to something. So what do we do? Well, we first instantiate I with 0, and I'm going to jump over the condition because we know that now we have to increment to get to 4, right? We have to go 0, 1, 2, 3, 4. We're going to get step by step over the array, so it's going to be I++. Now the condition, well, the condition is very simple. You only have to add in here I less than the size of the array. What is the size of our array? Well, 5. So if you go through the sequential methods that I went when I presented the for loop, you'll notice that it goes through I equals 0, then I equals 1, then I equals 2, 3, 4, and when it gets to 5, this condition is false and it exits out of the for loop. So that will be used to iterate the array, and now we can actually add to that sum variable the previous sum, and well, beforehand we did I, but that was because we were just summing all the numbers up until n. This time we want to sum the elements inside the array. Well, I is going from 0 to 4, right? So we go 0, 1, 2, 3, 4. So we can simply say A of I in here. I say A of I, and that would in fact iterate over each element of the array because I goes from 0 to 4. And we can simply print this out. So the sum of the array is and sum. Okay, and if we try to run this, the sum of the array is 61. Well, it's 10, 22, 37, 57, and 61, which is correct. So we're getting the correct number here. Alright, so let's play a little bit with this program. Now that we know a little bit about how arrays are assigned values and are actually iterated over, and we can also read values from it. Let's try and play with this and try to change our array so that it supports decimal point numbers. To do this is very simple actually. All you have to do is change the data type of this, right? So instead of having 5 integers, we can have, well, 5 floats. And in here we can leave most of these in here, but I want to change it just a little bit so we can see that in action, right? So let's say A of 4 is going to be 4.1 and 12, or A of 1 is going to be 12.6, okay? And you will notice that since we have floating point numbers, the sum of those floating point numbers is going to also be a floating point. So we also have to declare this as a float. And don't forget to print it as a float, otherwise it's going to do strange things. So if we try to run this, you will notice that we got, well, close enough. We got 61.699997, right? So this gives us a way of summing the numbers inside an array, and that array can have really any type we want, right? We cannot have arrays that have ints and floats at the same time, but we can have arrays that have all the same types, but really any type. Just make sure that they are the same type that we want. Alright, we have this program, and let's first go step by step and see what it does. So it first instantiates an array. We have seen this before. It's almost the same array we we had before. It's an array of size 5 and instantiated every single number inside of it. And then we have an I and a for loop that goes from 0 to, well, 4, well, or 5 exclusive. Alright, and then what does it print? It prints a number that is a of I. So it prints a of 0 and then a of 1, a of 2, a of 3, a of 4, because I goes from 0 to 4. Okay, if we try to run this, simple enough. This is what it did. It just printed out the whole array, right? We did print a of 0, which was here. That's 10, 12, 5, 8, and 1. Cool enough. Cool enough. But one thing that kind of annoys me is that why do I have to instantiate every single number, every single index inside my array on a different line? That's kind of annoying, isn't it? And it sure is, right? There's actually a solution, a better solution to this. You can actually instantiate this array differently than what I did here. And instead of typing in all this, what you can do is, well, let me just comment out this instantiation. And I'm gonna add it, let's add it down here. So instead of doing that, you can actually use the shorthand instantiation, which goes like this: int a of 5, so you're still declaring it, and we'll say equals, and then inside the brackets here we're gonna actually add in the numbers that we want to instantiate in every single index here. So in this case we would have 10, 12, 5, 8, and 1. And semicolon. And what that would do is exactly the same as above. So this says a of 0 is 10, a of 1 is 12, a of 2 is 5, a of 3 is 8, and a of 4 is 1. If we try to run this, you would notice that it does indeed give us the exact same result. So you can instantiate it like so. One more pretty interesting thing is that by instantiating it like this, you can actually remove the number between brackets, between the square brackets. So you can actually just delete this and the program will still be valid. If I try to hit F11, you'll notice that it would still show us the same result. Well, why does that is pretty simple. It's because now we don't have to specify a number, because it already knows that, oh, this thing that you gave me, it's how many digits, how many numbers long? Well, 1, 2, 3, 4, 5. So it just counts how many are in here and just pastes in between the brackets automatically. So you don't have to do it if you don't want to, really. Okay, so keep in mind. But you will have to add the number in between brackets when you're just declaring it. You cannot do, there's one limitation, you cannot do something like, let's say if I cut this and say a equals that, sorry, like that. And if I try to compile this, it would give me an error because it doesn't know like how many numbers in the array you want. Like there's no way at this line to know exactly how many. If I give it 5 though, and I try to compile, now this guy is giving me an error. Because this type of instantiation, the way you initialize the array, can only be done when you declare it. Right? So keep this in mind. You cannot do it like so after you declared it. You have to do it exactly the same time as your declaration. Alright, so let's play a little bit with this concept of arrays. I have declared here an integer array of the same size as before. I changed a little bit the values, and in here let's try and verify if any number inside the array is odd. Okay, so we want to know which number is odd inside the array and print it on the screen. Now it seems simple, right? All we have to do is do what first? Well, you have to realize that first we have to iterate over the array. Why? Why do we have to iterate? Well, we have to check each number. Well, not necessarily in order, but it would be much easier in order, right? So we have to check each number in the array. So we have to iterate over the array. Don't forget this term of iteration. To do this, well, we will start. In a previous lesson, we used a for loop. Let's try a while loop this time. So int I, we need an I as before. While the condition would be what? I less than 5, and at the end we're going to say I++. Simple enough, right? And in between here we do what? Well, we have to check if the number is odd or even. How do we do that? Well, I talked about that in a previous lesson, and it's simply a matter of checking a variable x, let's say this time, percent or modulo 2, if that is equal, if that remainder from the division of 2 is equal to 0, right, the comparison and then 0, then the number is even, so we print f number %d is even, and let's also give it a \n. I'm just gonna put in x here, but we already know what's gonna be in there. Think about what has to go inside that to replace the variable x in there. And on the else branch, we have number %d is odd. So, like so, that's how we did it, right? We only want to print if the number is odd. We want to ignore whether or not the number is even. Okay, well, sure enough, we can do this. We would simply need to reverse the if. So I'm going to say if x%2 equals 1 this time, and bring out this printf here and delete this line, and also ignore the else branch because we don't do anything with that. And this way we will print only the odd numbers. We won't print the even numbers at all. And if we try to run this, we're gonna get an error because x is undefined. So we have to replace this x with a different variable, and that variable would be what? Well, it's going to be a of I, right? You can use any variable in here. You can even have more complex things in here. It will always check whether or not the number is odd or even. So in this case, if we run this, you will notice that it's going to print out number 5 is odd and number 1 is odd. So what did this, how did this work? Well, we went over the first element in the while loop. We initialize it with 0, and then we entered the while loop because the condition was true. And here, so the first element was 10. So we said, okay, well, 10% 2 or modulo 2 is, well, 0, which is different than 1. So we didn't do anything here. We just went forward. Then we checked a of 1. Is a of 1 modulo 2 1? Well, yes, actually, because 5 divided by 2 is 2, but the remainder is 1. So the number is odd. And increment a of 2 is 12. Then we replaced a of I with a of 2, which is 12. So 12% d, modulo 2 is 0 actually, because 12 divided by 2 is exactly 6, no remainder. So we didn't print anything inside this if. We went past that. We got 1. 1% or modulo 2 is, well, 1. If you divide 1 by 2 is 0 remainder 1. So it printed this number. We went past that. A of 4 is 8, so we got 8 per modulo 2, which is 0 because 8 divided by 2 is 4, but there's no remainder, so we didn't print anything. And we incremented past 5. We got I to be equal to 5. We compared 5 with 5 here, so we said, is 5 less than 5? Well, no, it's not. So we got out of this while loop and the program terminated. And that's how you can actually check lots of things about elements inside the array. If you want to check a certain property for every single element, don't forget, you have to iterate each element inside that array. So one more data type I want to touch upon in this tutorial is the character data type. And the character data type is, well, as the name implies, a type that can store characters, or more exactly one character. So to instantiate a character type variable, we simply type in char, give it a name as before, and to initialize it you will have to put in between single quotes the character you want to have inside that variable. For example, c equals the character s, alright, and then a semicolon. And to print it you will simply have to do printf, and the character is, and as before we have a special character here, %. It's not %d, that was for integers. It's not %f, that was for floats. It's %c this time. And %c says, alright, I'm expecting here, after the comma, a character. Alright, I'm going to give it c, and semicolon. And if I try to run this, you will notice that it did, in fact, print the character s on here. And you can do this for almost any character. It's somewhat limited, but you can also have things like numbers in here, as you will notice, as the character 5. And you can also read a character. That would be done through, well, the scanf function, as we did before. So now instead of %d or f, just %c, and this one expects again a character type, but don't forget the ampersand, as it's different from the printf function, and semicolon. And well, let's not initialize this. And now we're just reading a character and printing it to the screen. So let's try executing this. This guy now expects me to type in a character. If I type in k, it will just say the character is k. So now we have a way to store characters. Amazing. But wait a minute, you say. Didn't we learn in the past that computers can only store numbers? Like, all they are doing is using ones and zeros to do the computations. That's all they know, ones and zeros. And then how in the world are we storing inside this variable a character? We cannot really fit inside the memory a character. We cannot just mash it down and make it actually store a character inside of there. So what is the program actually doing if it cannot store a character? Well, let me tell you what it's doing. It's actually translating this character s into a number. Alright, so this, when I say char c equals the character s, we're actually assigning to c a value, a number that just represents the character s. We're not actually storing the character s inside of there. It's just the the ID or the number, or more correctly the ASCII code for that character. You may have heard of the ASCII table, and that's a way to map integers to characters, right? So we're mapping integers to characters, and now we can actually store double quotes characters inside computers, basically. So to better demonstrate this, you can try actually replacing this single quote with the following number. You can just type in here 115, so 115, and if I try to run this now, so F11, you will notice that it printed to the screen the character S, because in fact the code that represents the character S is 115. So that's how you can actually store, that's how the program stores characters, right? Through a number. And here it is, here's the ASCII, the whole ASCII table. You can see right here that I did take the 115 from here, and it just so happened that it was the character for the S. And here are all the codes. It goes from 0 to 127, right? And you cannot, like, you only have a couple codes. You don't have some other more complex alphabets in here. You're just limited to the English alphabet and a few signs and the numbers. You will also notice that the character for 0 is just the number 48. It's not the actual number 0. So if I say here single quotes 0, if I try to hit F11, it says the character is 0, but if I do, instead of 0, if I say equals 48 without the single quotes, here we're just translating it ourselves. If I hit F11, you will notice that it also prints out 0, because in fact the character 0 does have the code 48, right? So just keep this in mind, just keep this table in mind. We're just storing numbers, we're not doing anything more different than that. It's just that printf knows how to print characters. When I say %c, it knows that, oh, this guy wants me to print a character, so it looks here, oh, you are a character, what value are you? Oh, you're 48, well, let me look into the ASCII table. 48, 48, 01, 15, 31, 48, here it is. Oh, you want the symbol 0 on the screen. Alright, let me print that for you. Bam! And that's it. That's all it does, right? So keep this in mind. The computer doesn't store the characters, it stores IDs that represent those characters. Alright, so let's play with this concept a little bit of storing numbers that represent characters inside our data type char. Alright, so let's delete this. Okay, and let's try first reading the characters. So we're gonna say scanf %c and comma %c, right? So this c is not the same. We can have here like any name here. Don't worry, this c doesn't correlate with this c. It's just that I named them the same. Anyways, we're reading a number, we're reading a character, and we are printing it to the screen. So if I try this, if I try this and type in, for example, R, it's going to say the character is R. Cool. Now, what happens if I actually do operations with this character? Since it's a number, right, we learned that, oh, when I typed in C there, or when I typed in the character R, when I typed in the character R, the program looked in here and it was like, oh, well, R, there it is, 114, cool. So we had the number 114 inside there. How can we change that? Can we actually work with it? Well, in fact, we can actually change that. We can say C equals C plus 1, or just, C++. Yeah. So we're just adding 1 to the character C. No, we're not adding 1 to the character C. We're adding 1 to the ID that represents the character C. And that ID is a number. Okay. So when I type in R and hit enter, you'll notice that it went to the character is S. Well, let's take a look and let's see what happened here, because it's kind of interesting. Let's see, yeah, I can fit them in the screen. So we typed in the character R, right? So here it is, here's the character R. Inside that variable, we stored the value 114. Alright, so right here we stored the value 114, but then we added 1 to it. So when we added 1, this 114 changed to 115. Fair enough. And when we tried to print to the screen, we're using printf. Printf looked here and say, okay, you want to print a character. So it looked here, it looked at the value of C, which was 115 this time, and looked inside the table, 115. Oh, that's the character S, and that's why we got the character S this time. So we can actually change the value that is stored that represents the character inside there. We can actually do a lot of we can actually do any operations that we did with the integers or even floats. So that's that. Keep this in mind. You can do this, no problem. Let me demonstrate it one more time. If we try and do, for example, the character 2, it says the character is free, but it didn't add 1 to 2. It actually added 1 to the ASCII code of 2, which was what? 50. So we stored 50, we added 1, that made it 51, and we printed to the screen the character free. That's what happened. So hope that's clear. Well, since what we're storing inside this character is a number, we can actually also compare two characters, right? Because, well, they are just two numbers. We can simply just try to compare them. Is one higher than the other? It is, or it is not, right? So let's try doing a simple program here. Let's try checking if what we're typing is a lowercase letter. Alright, so I want on the screen, whenever I type in, for example, uppercase A, it will say that, oh, you typed in an uppercase letter. And when I type in lowercase a, it will say you typed in a lowercase letter. So let's try this. So we read the character here, and we need an if statement. You might notice that. And here you will have to check if C is higher or equal than what? Well, let's look at the ASCII table and see how it's structured. Okay, so if I look in here, let's first check if it's uppercase. Okay, if I look in here, A, B, C, D, E, F, G, it's all a continuous sequence, right? So we can check if our number is between A, or 65, and 90. Okay, so we can certainly just check that. We can say, okay, is what was it, 65, right? So C is higher or equal than 65. Then if C is less or equal than 90, then you just print F the number is, or the character is uppercase. And let's just also print the character here, the %C character, and we're gonna say C here. Cool. So that's how you would do it. And right, so we're basically checking if it's higher or equal than 65 and less or equal than 90. Okay, that would be the uppercase part. Let's try this and see if it runs. So if I type in, for example, uppercase F, it'll say the F character is uppercase. Amazing. But if I type in the lowercase e and hit enter, nothing prints to the screen. That's expected. Okay. Now let's check for the lowercase. It's almost the same thing actually. You can even copy and paste this. I'm gonna retype it. So C higher or equal than, well, now it's not 65. We have to look which number it is. So lowercase a is right here. Okay, so that's 97. And lowercase z is 122. And as you will notice, the lowercase and uppercase are different. And they're also in a continuous sequence. So you can just check if it's in between these two numbers. Then it's a lowercase letter. So 122 and 97, okay? So 97 and c less or equal than 122, was it? Yes. Okay. And then we can print f a message. Let's say print f, the %c character is lowercase, and c. And now if I try to run this, let's try lowercase b. I'll say the b character is lowercase, and uppercase d, the d character is uppercase, and it would do that for every single number, even z uppercase, right? That works for every single number. If I type in a non-letter like 4, it won't print anything because, well, let's check what happened there. So 4 would be, let me find the ASCII table here. 4 has the value 52, right? So the program went here and said, all right, is c higher or equal than 65? Well, it's not. 52 is less than 65. So we skipped over that if. Then we went here. Is c higher or equal than 97? Well, no, it's not. So we skipped over that as well. And that's what happened basically. We didn't print anything because 4 is not in between those intervals. I hope you got something out of this. Now, the cool thing about C is that you can do, instead of using 65 here and 90 and 97 and 122, you can actually use the character uppercase A, and here you can use the character uppercase Z, and in here you can use the character lowercase a and lowercase z. Now, I know I have started with the numbers, I just wanted to prove a point, but you can definitely do this. And see what C will do behind the scenes is take this thing and look up the ASCII table. So it go, okay, well, it won't access the internet and won't have a browser, but still it would do almost the same thing. So it would say, okay, well, you gave me the character uppercase A. Well, let me take a look and see where can I find uppercase A. So and here it is. Oh, uppercase A. Okay, let me take that number. So 65 just kind of copies and it just pastes it in here. That's all it does. So it's a little bit simpler to do it like this, but I wanted you to know exactly what happens inside the program because, well, this is very important. We have this scenario. So we have a simple program and it's printing in hello. So if you run this, of course, it's a simple hello world program without the word. Okay, it's printing that. But we want to be able to change this, and dynamically, I mean. So for example, I want to, I don't know, change this into a question mark if something is true, or change the text itself to something else, or add to this text and say hello Andrew. Be able to do that. How can we do this, and how can we accomplish this? Well, we have to work with strings of text. And what is a string of text? Can you think about how, like, what could that be from what you've learned so far? Take a moment and think about it. The answer is simple, actually. A string of text is just an array of characters. We already have characters, so we can store individual characters. We have arrays which stores multiple things of the same type. So we can just mash them together and we have a character array, also known as a string of text, right? So how can we do this? Okay, well, let's try and print in here this text, but dynamically from what we know so far. Okay, so the first thing we have to do is, well, define our array. So let's say char, let's say text, and it's going to have how many characters? Well, let's count 1, 2, 3, 4, 5, and 6. Alright, so 6 characters. Amazing. And let's instantiate each one of them. So text of 0 equals, well, the character h. Or you can also use the number from the ASCII code, which, let's see if I have it here. Yeah. So also you can use the number 72. That works as well. I'm gonna be using this just to be able to see what we are actually typing in here. So remember, the program does automatically paste the number in there, so we don't have to worry about that. Text of 3, that would be L, text 4, O, and text 5 equals exclamation mark. Okay, fair enough. And let's try and print this. So you might know that we used %c to print a character. So let's try using this. So %c, well, we're gonna have to print 6 characters. So I'm gonna have to copy and paste this %c, well, 6 times. So 3, 4, 5, 6. Alright, so 6%cs, and then, as you learned in the past, you can use printf to insert multiple values inside of the text that we are inserting here. So we can say here text of 0. So text of 0 would be, well, this %c, right? This would correspond to this one. Okay, and then if we continue on with this, text of 1, text of 2, text of 3, text of 4, text of 5. It barely fits on the screen. Alright, so that's what we do. We just kind of add %c's right there. So this is going to be this one, and then this guy is going to be the next one, and then and then the last one is going to be the last one. Right? I hope this makes sense. We're just getting all these values and inserting them in here, and then we're printing that to the screen. Okay, so if we try to run this, F11, we're printing hello, right? Because in text of 0 we have the character H, and then in text of 1 we have the character E, and so on, and we're printing it in order, right? But there's one issue. Well, first let's look at the initialization. I don't really like this. Is pretty annoying, right? We can use the initialization, the shorthand initialization for the array. So first let's delete this and add in here, if you remember, equals brackets, and inside brackets we just add values. So H, E, L, L, O, an exclamation mark. So that would instantiate this array with these characters, or these numbers that represent characters. And if we try to run this, it will still work, no problem. So that's amazing. Now, I have an issue with the way we're printing here. It's not the greatest way, right? You have to print this every single character. If I have a string of like 200 characters, what in the world do I do? Okay? You can use a for loop, I guess, yeah, that would work, but do you really have to do that for every single string of text you have? No, you don't, and I will go through how you can do this in an easier manner. Now, for printing out a string of text, there's a special character again for printf. Instead of %c that we did for one single character, there is, well, it's called %s from a string of text. And this guy prints multiple characters. And you have to give it a string or an array of characters, right? So instead of text of 0, 1, 2, 3, 4, 5, we just type in here text. Alright, but there's a problem. There's a not so obvious problem, but there is one. How in the world does printf know how many characters to print? You remember, right, we did %c, well, 6 times because we had 6 characters, but this time we don't do that, so how does it know? Like, it's no magic, right? It can't be magic. It can be like, oh, you declare this of 6 and then kind of know. No, it doesn't know anything about this type the way it was defined. So how does it do it? Well, behind the scenes, there's an interesting character that has to be added at the end of the string you want to print on the screen, and that is the character that is represented by the value 0. Let's go and take a look at the ASCII code, right? So here there's a value with the values, there's a character with the value 0 that's called null. The null character in C means that that's the end of the string of text, okay? Every single string of text or array of characters should have a null character at the end, okay? So what you have to do here, instead of saying text of 6, you will have to say text of 7 and add another character, which is right at the end. So you add it here, you just say, you can do either the value 0, that would really mean the actual null terminator, or if you want to use this same notation, to do that you will have to put in between the single quotes the value \0, and that's a special character for the null terminator, okay? Alright, so now if we try to execute this, you will notice that it does print hello on the screen. Now, well, let's see what happens if I don't add this, right? If let's say I forget about it completely. So if I just delete this and just change this to 6, F11, well, it still prints out hello, alright. But that's just due to chance. In computer science, sometimes the memory kind of works for you and it aligns with what you need, but it's not always guaranteed that you're going to be printing hello. You might be printing more than that. The compiler just so happened that it saw that the length was exactly 6. Alright, but to make sure that it always works, you have to add this \0 character, or just the value 0. I like the \0 more. Alright, and just add in here 7, or just delete it altogether. If you remember correctly, this works the way it should, and if I hit F11, it does print out hello. I hope that's clear. I hope that you understand now why we need to put this character, because otherwise we wouldn't know how long this text is, and printf wouldn't actually know, well, how many characters it should print. Okay? Alright, one more shorthand initialization this is special for the character array or for the string of text, instead of doing all this, you can just comment this out and type in text, text equals, and this time you will have to type in double quotes, like that, the text you want to print on the screen or manipulate or something. So I type in hello, for example, and exclamation mark and semicolon. And this is actually equivalent to this, right? So you will notice that it automatically puts the \0 at the end of this. All right. And if I try to run this, of course, we still get hello. So that's the shorthand. We can simply remove this now altogether, and this is how you can, well, initialize some variable with some text and then print it. And now in between here and here, right, in here you can actually manipulate this text, which we're gonna get to in the next lesson. Okay, so let's try and play with this concept of strings of text. First, let's try to simply change this exclamation mark to a question mark. So how would you do it? Think about arrays and how you would assign values to arrays first, and well, pause the video if needed. And alright, now if you thought about it, it's actually pretty simple. The way we initialized our array of characters tells us how to actually replace that exclamation mark. What we have to do is simply change one character and assign it a different value, okay? Which character is it? Well, we have to count here. So text of 0 would be that H, text of 1 would be E, text of 2 would be L, text of 3 would be L, text of 4 would be O, and text of 5 would be the exclamation mark. So text of 5, that's the one that we want to change. So text of 5 equals, well, we want that to be changed to a question mark, okay, and semicolon. And now if we run this, you will notice that we now have a question mark at the end. That's amazing. That's nice. That's very nice, right? We changed the initial text dynamically. We could do this for every single character, and it would be, yeah, it would work. We would print something dynamic to the screen. Amazing. But there's some limitation to this, right? Like, what if I want to replace every single exclamation mark with a question mark? Let's see if I have like 3 here. Well, I really have to do something like copy paste and then just go, oh well, 6 and 7. Yeah, that would work, right? Would just replace it. But if I have 20 of them, it would be very tedious. And if I have them like here or here, it would be also very tedious. So how can we do this dynamically? Well, the simple answer is to just iterate the array, like we did in the past, right? We need to do some operations for every single element in the array, right? We have to go, okay, well, this is the array, and we want to take every single character in that array and ask it, are you an exclamation mark? Are you an exclamation mark? Are you? Are you? If you are an exclamation mark. Well, let me replace you with a question mark, and so on. Alright, so to do this, what we have to do is just, first, let's iterate over this array. So, let's say here 4, let's first declare an I here. I equals 0, I less than, well, how do we know the length of the array? How can we know this length? That's a bit of problem. We can count for now. Sure, let's do that. Might work. So 1, 2, 3, 4, 5, 6, 7, 8. Cool. So it's 8. So that's how many we're gonna add here, and then I++. Okay, and inside here we're gonna check if what? Well, we're iterating with I from 0 to 7, and we want to check text of 0 through 7, right? So text of 0, text of 1, text of 3, each character one by one. So if text of I, remember the comparison, the comparator between two numbers to check if they are equal is equal, right? Double equal sign. And in here we have to compare it with, well, the character exclamation mark, right? And of course the program is just gonna go here and look at the ASCII table and go here it is. Oh, there's an exclamation mark. So I'm gonna get that and I'm gonna copy this 33 and paste it in there. It's gonna do it for us automatically. We don't have to bother with it. Okay, so we just check, and if that's true, we're gonna assign to the same thing, text of I, the value question mark, right? We just replace them, and semicolon. Alright, so we just iterated over with our for loop, and for each character in here we checked if it's an exclamation mark. If it is, we replaced it with a question mark. Let's try and run this, and you will notice that this worked. This in fact worked. It said hello and it questioned us. So that's how you would manipulate text somewhat dynamically. Now, one issue I have with this is, I don't know if you might notice that, but what happens if I just add more exclamation marks? Let's say if I add 2 more, right? So we have 5 exclamation marks at the end. Let's hit F11 and see what happens. And oh, what? We no longer change all the exclamation marks to a question mark. Why is that? Like the last 2 are not changed. Can you think about why this happened? Yeah, this is a problem because this iteration is no longer correct. This for loop doesn't iterate over the whole array now, is it? If we count the characters, let's count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. So we have, so the size is now 10. I have to change that every time. That'd be a pain, wouldn't it? Yeah, that would be a pain. To change that to 10, and then if I delete some, you have to change that to 5 or something. It would be a pain, right? So to solve this issue, you can dynamically find the size of this array using a library. Okay, so to do this, you would simply have to add in here up top. This is a place where we haven't changed things yet, but it's a simple place where we say, okay, well, we're gonna use some extra things. Just think of it like this. And in here we just have to type in hashtag include, and in between angled brackets we type in the name string.h, and that's well, they just add some functionality that manipulates text for our program. Think of it as that. I won't get too much in detail as to how this works, just remember to add it here. Okay, and now that functionality is very simple to use. There's a function now called strlen. Alright, so strlen, and parentheses, and in between we have to give it the string, the character array that we want to do some operations with. So we just add in here text. And strlen is a simple abbreviation from string length, right? So strlen, that's where it comes from. And you might realize now that what I'm doing is basically getting the length of that string, and this function calculates it for us. We don't have to do anything, and it will automatically paste in here any number we have, any number of characters we have in here. So if I run this, you'll notice that now we're replacing all the exclamation marks with question marks. And if I add even more, let's say if I add 3 more, it will also change those into question marks. So that's how we get the length of a string in a dynamic way. Now we learned how to iterate over a string of text of any length, right, using this structure. Okay, so keep this in mind. So let's say instead of this hello string in here, we want to type something on the keyboard, and it would automatically replace all the exclamation marks with question marks, and then show us that processed line of text. How can we do this? Well, it's actually pretty simple. First, let's remove this initialization. And then since we removed that, we need to actually decide on a number here, right? We need to know how long the array is. And this number would be basically a maximum number of characters that you want, that you can actually type on the keyboard. So let's decide on, I don't know, 100, for example. Right? 100 characters is long enough for any sort of simple message. And then after that, let's print a message. I don't know, type a message. Okay, and then after that, we need to call a different function that we have called before. Before we have used scanf, right? We did scanf and then %s. We would be doing that, but this is not the way to do it for strings of text. Okay, I'm not gonna go into the details of why that is, but just keep in mind you cannot use scanf for reading lines of text. Okay, so what we have to do instead, we have to use a different function called fgets. So fgets takes in 3 parameters, right? So first we have to type in the array, simple enough, comma. Second parameter would be the maximum number of characters we want to read. Well, we already decided on that, and we said 100, so 100 is fair enough, comma, and then this third parameter you have to type in here std in. Okay, don't worry about what that actually is, it's just basically standard for telling it to take input from the keyboard. All right, and now if I try to run this and say, okay, it says type a message, hello world, and hit enter, it replaced our exclamation marks with question marks. So it did work, it did actually iterate over. That's amazing. Now there's one more thing I want you to keep in mind. Well, let me just add a different text in here. Let's try a hi, for example, and put an exclamation mark and then hit enter. Yeah, that would actually work, right? But let's find the length of this text. Okay, let's find the length of this text. So right after we've processed it, the length of the text is, I'm gonna say %d, and also an enter for the purposes of better viewing the text that we're printing on the screen. Let's say just strlen of text, and I would just insert the number in there. And then if I try to run this, if I type in hi exclamation mark and hit enter, you will notice that the length of the text is 4. That is not actually correct. is it? We printed out, we typed in 3 characters only. We should have iterated over only 3 characters. Why is there 4? Well, long story short, remember this \n? Yeah, when we hit enter, that \n gets inserted into our text right at the end. So what we have to do is to get rid of that \n. Okay, and to do this, it's not particularly difficult. What we have to do is just find where that \n is. All right, let me draw a little bit on the screen here, and let's see for hi, right? So we have this text hi, and let me just get here. So we have let's say I, and we have text of I, right? So that would be my iteration, text of I, and that's a table of 2 columns. So for I equals 0, well, what's the first character? Would be, well, let me get my console here, would be H, right? So simple enough. So it's the character H. The second character, 1, is I. The third character with the index 2 is exclamation mark or question mark, that gets changed right in here, right? The third character is actually that \n. So I have this, really this thing. So whenever you hit enter, you actually get this into your text. So we have to replace this with, well, we want to replace this with a \0 actually. That wasn't too, let me see, right, with a \0, because we don't want that \n to be there all the time. How can we do this? Well, let's figure it out. What was strlen of our text? It was 4, right? So we want strlen of text -1. That would be, right, 4 minus 1 is 3. That's the index that we want to replace. Okay, which means we have to go here and say, well, right after we read this, we have to say text of, right, we want 3, but dynamically. If I say hello, I want, well, the last one. So it's going to have to be strlen of text -1, right? Since in our case hi is 4, it would be 4 minus 1, which is 3. So this would be text of 3, which is what? Our \n. And we have to assign that the value \0, since we want that to be the last character. At the end here, f gets also puts the last character \0, but it's one position further, so it's not the greatest place we want. We don't want it there, we want it up here, right? So this has to be equal to \0, or just the character 0 if you want to, like that. It's the same thing, right? So I hope that's somewhat clear. If not, you can just play with it and try to work with the text a little bit and see what I mean by that \n being here. If not, you can just use it as it is. This makes sure that you get rid of that \n, which you might not really need. Okay, and now if we try to run this, so let me just remove the screen here, top. So F11, and I say hi, you will notice that the length of the text is 3 because we just moved that \0 1 character over, and it just made strlen calculate the string differently. I hope that's somewhat clear. Really. It could be a little bit more complex, so I'm sorry about that, but we have to go through this. So let's say I want to also keep our previous message intact and, well, print that later on the screen, right? I want to print a message that involves both the message that we typed and the processed message, right? So both the one with the exclamation marks and the one with the question mark. How can we do this? Well, it seems pretty straightforward, right? You have to basically copy that text with that with those exclamation marks into another place in memory. So copy it first and then print it later on and process the initial one, right? Well, okay, so to do this would be simple. We just have to first declare a place in memory to store this, so another variable. So let's call it text copy, right? And the size, the maximum size, let's keep it 100. We're still reading the text. After we read it, let's copy the text. That's very simple, actually. All you have to do is type in strcpy and then the first parameter is a function, and the first parameter is where you want to copy the text. So you want to copy into the text copy variable, and from where you want to copy. So what's the source? That will be our text that we read with this function. Okay, and semicolon, and that will actually copy our text. strcpy is an acronym from str string copy, right? So that's where it comes from, and that's what it does. It just copies from here to here, right, from right to left. And if we print this on the screen, let's do this. Let's just say, and it's copy %s. Let's say text copy here. And if I run this, hello there. You will notice that we also have the one with the question marks and the one with the exclamation marks. Right? So I hope this is clear. It's just a simple copy, simple operation with the text. Just make sure you don't forget to include the string.h library. Suppose you have this code. So this code simply has a greeting with the text hello in it, and it just prints that greeting, right? So if I run this, it just says, well, guess what? Hello. What if I want to just query the name? So it's gonna ask me the name, and what if I want that to print hello and then my name, right? I want to concatenate my name to it. How can I do this? Well, there's a function for that. So let's see. First, let's read the name somewhere. So char, say name, and I don't know. I think 50 characters is good enough for a name. Pretty sure nobody will have a longer name than that, I think. And in here, let's print f. What is your name? And you have to type in here, right? We learned in the previous lesson how to read a line of text. We use the fget method. So fget name, then here 50 characters maximum, and then std in. All right. So that asks us for the name, and after did that, we just have to do what? We have to use the function called strcat, right? And in here, like in the function strcopy, it will ask us for two strings of text, right? One is the destination, in which it's going to put the concatenated string, and the other one is the source, the string that you want to concatenate. So we want to concatenate into greeting, so on top of greeting we want to put something, and that something is, well, our name. So just type in name and then semicolon, and now it should print out hello and our name. Let's try this out. If I hit F11, it's gonna ask me for the name. Let's say my name is Alice. Works for me. And now it says hello Alice. Well, that's not great. It also added our \n beforehand, so we're gonna have to fix that. It also didn't add a space in between. It doesn't know about spaces. So this function strcat, which by the way comes from strcat, is from string concatenation. There we go. So that's where it comes from. And first things first, let's solve that issue with the \n. We talked about this in the past. So name of strlen of name -1 equals \0. So that would just get rid of it completely, of the \n. All right, and in here, before concatenating the name, we can do something nifty. We can simply strcat to greeting. We can concatenate a simple space. All right, so let's try this. Just a space in here. First I hit F11, and let's see what happens. All right, so let's type in here Bob and hit enter, and oh, our program crashed and we are just, it's dead. It's completely dead. Well, what happened? What happened here is that because we typed in single quotes, the program looked into the ASCII code, right? Whenever you have single quotes, it looks at the ASCII code and it replaces that with the ASCII code. So if I have this here, I hope, yep, there we go. It looked and tried to find the space character. The space character is right in here, right? So it's 32. So it went found it, and it replaced what we typed in here with 32. But that's not good, right? We don't want the number 32 there. We want a string of text. So keep in mind, a character is different than a string or an array of characters of size 1, right? So in here we have to actually use double quotes, right? Notice the difference. So double quotes instead of single quotes, like we did here, because it's a string of text. It's an array of characters. All right, it's not just one character. Even though we are in fact adding one character, the functions that use strings have to take in an array of characters. Even if the size of that array is just 1, you cannot push onto it just one character. It doesn't know how to use that. Okay, so if you hit F11 now and ask for our name, let's say, I don't know, let's say Alice again, and hit enter, you will notice that it did add in the space right there, and also removed the \n we had in before because we added this replacement. So, right, that's how concatenation works. We just first concatenated the space, and then we concatenated the name, and inside greeting we had the whole thing put together. And we can add even more to it. Like, nobody stops us from actually adding, I don't know, we can just add greeting, and let's add more exclamation marks. Just F11, sorry, I forgot the semicolon, F11, and if I type in here Bob, it will just add more exclamation marks. How's that? I hope that's clear. So that's how concatenation works. Pretty simple. Just make sure you use arrays of characters and not characters by themselves, as it will cause errors and you will waste a lot of your time finding out why that's not working. Alright? Alright, one more little algorithm I want to go through for string manipulation. So we have this code and we're reading the name, right? We did this in the past lesson and we read the name of a person, right? It just asks me the name here and I say, okay, well, Bob, hit enter, it says hi Bob. Alright, well, what I want is an algorithm that capitalizes every single letter, right? So it just goes through every single character in there and it checks whether or not it's a letter, lowercase letter, and it changes it to uppercase. How can we do that? Well, first things first, we have to iterate the whole string. Fair enough, so let's do that. This time let's try a while loop. So I0 while I less than strlen of name, and then I++ right here. Okay, and in here we will need to check, right? If we did this in the past, right? We did name of I is higher or equal than the character A, right? We want to capitalize any lowercase letter. We don't want to capitalize the exclamation mark or something like that. We don't want to capitalize any uppercase letter. So we want to check if it's a lowercase letter. So if name equals that, if name of I less or equal than Z, then in here we are gonna do the transformation. So we're gonna say name of I, because that's the one that we checked so far, equals, well, equals what? Can we figure out what we need to do here? Well, sure, we can do an if else for every single letter and just say, alright, well, if name of I equals, I don't know, F, then name of I equals F, and so on. But that would be very tedious, right? We already know that the letter is lowercase. Let's take a look at the ASCII code, ASCII table actually, and let's see how they are structured, okay? So if we take a look here, lowercase a has the value 97. Cool. Uppercase a has a value 65. Okay, so the difference between, what's the difference between those two? The difference is 32. Okay, cool. Let's take a look at another letter. Let's say H. H has the number 104 and uppercase H has number 72. What would that be? Well, that difference is still 32 because they are in the same sequence. Oh, so what we can do is if we get any number in here or in here that is lowercase, we can just subtract 32. So for example, we have like 112, right? What is 112 minus 32? That is exactly 80. And if I take a look at the number 80, oh, look at that, that's uppercase P. So the simplest way to do this is, after we checked that the number is lowercase, is to just subtract 32. Okay? So you can say name of I minus equals, I'm going to use the shorthand. If you remember, that's the same of saying name of I equals name of I minus, well, minus 32 here, so minus 32, right? So if that wasn't clear enough, minus equals is a shorthand for the one at the bottom. And if we do this, let's see what happens. Okay, so let's try and run this. And it's going to ask for my name. I'm going to say Alice and hit enter. And you will notice that it did in fact capitalize every single letter. The one that was already uppercase, it didn't capitalize because we checked in before. So we're iterating for every single letter in our name. We checked if it's a lowercase letter, right? It's between A and Z because it's a continuous sequence inside the ASCII code. You have A, then you have B, then you have C, up until Z, right? So if it's a lowercase, we simply subtracted 32. And that's all we did, nothing else. And it already worked. Okay, so you can do all this. You can play with this a little bit. You can actually try to lowercase all the uppercase letters and so on. You can change a few letters. You can check if, I don't know, if there's a vowel in there. You can count the number of vowels. You can do whatever you want with this because they are just numbers. Nothing different than that. Okay? Now, there's also a function that does this already for us. We don't have to do this ourselves, so we can just remove this whole algorithm. Or actually just, I'm gonna comment it out. So like that. And below, the function, the following function, strlwr, and the name, does automatically convert our name to, oh sorry, I didn't do it. Alright, it was strupr for uppercase, sorry. So let me try rerunning this. Come on. Yes. Yes. Alright, so what is your name? And now if I type in Bob, it's going to capitalize our name. So strupr actually does that for us. What we did here, it's basically the same thing. And there's also the, as I typed the wrong function, there's also strlwr, which comes from, so strlwr is string lower, and also strupr is string up, something like that, right? So that's how they work, and it's just going to make all our letters lowercase. So if I say Alice, you'll notice that it made my uppercase A lowercase a. So I hope that's simple enough. I hope you can understand why these really simple functions, you don't have to recreate them, but that's what they do. Now I have this simple program. If I run this, if I say, alright, well, this one wants me to type a number, so I can say 4 and 7. It's just gonna show us the result of the multiplication of those two numbers. Simple enough, right? We just kind of declare, read, and then calculate the result, and then printf, right? And we're using multiple variables here, right? That was simple. But one interesting thing here you will notice is that we are repeating something. We are repeating ourselves quite a lot here. We are saying type a number and scanf, and we're reading a number here, and then we're going to say this again in our code, right? And if I want to read another number, I'm going to have to add 2 more lines of code, and then 2 more lines of code, and so on and so on and so on. It could get kind of tedious. There is a way in which we can simply condense this into just one line of code, and that way is called functions. Think of functions as some sort of way to condense code into something, right? So I have just some code that you can actually call whenever you want. I can say, okay, well, now execute this code, right? So where our code executes line by line, we can say, okay, well, now I want to execute this code that we saved later on, and we said, okay, well, do that and do this, and it's a bit complicated. But let me get into functions, and you're gonna understand exactly what I mean. So functions have a type, right? First thing is the type that it gives back. We call that returns. Okay, so it first gives back an integer, okay, and then the function has a name, so we need to call it something. Well, let's call it read number, okay, and the syntax goes like this: parentheses, closed and open and closed, and then brackets, and in between brackets we have that code that we can recall anytime, right? And what do we want to do here? Well, we want to read a number. That's what we want. So to read a number, as we did in the main function, you'll notice this is also a function, you will do it like so. First declare a variable, so let's say int x, right? So it's called x. Then we print f a text so that we know that the program is waiting for us to type in a number. So type a number, and then we scanf, right? We just do this and %d, and we already know this is %x. Okay, cool. So if we try to compile this, F9, everything is alright, but not everything is actually alright. There's one problem. We have some way. We have to tell the program some way that, oh, well, we want to give back this x that we declared, right? Because, well, we read it, but we don't do anything with it. So I have to give it back somehow, right? We just kind of, okay, you call this, but you have to give me something back. Like, that's why I called you. If you don't give me anything back, then what's the point, right? There's a point to that. There might be one, but this time we want to just give me something back in return. To do that, we have to say return, and after return we have to say a value. It can be anything. It can be 7, 20. It has to be the same type as this one. So it has to be an integer, a whole number. It cannot be the text. That would ruin everything. So we can say 10, right? But that's not a number that we read. So we want to return, well, x, because that's the number that we actually read into memory. And now we can go ahead and use this function. How to use it? Well, we have to simply say, okay, well, read number of nothing, because there's no parameters, and just call the number. So we just call the function here. Just type in the number, the name of the function, and then open and close brackets and semicolon. And now we call the function, but we need to also do something with that value that we return. So right, we return x, but we don't do anything with it. So let's say a equals read number. Okay, what does that do? In fact, that simply does what? So let's think about how the code is executed here. We go line by line, right? We first declare this, it's all right, and then we go here. Here the program says, all right, well, I have this thing which I have to get a result from, right? So it goes here, right here, and it starts executing line by line from here. So it first declares x, and then it prints this number. It waits for the, oh my god, wait, it waits for the user to type in a number, and then it sees this return. This return statement is special because what this tells the program is, oh, well, you return something, then we go back here. Okay, so it goes here, executes, computes the value, and then when it comes back, it replaces this whole thing with the value of x right there. Okay? And then a will be equal to x, which in turn is actually the value we read from scanf. Okay? So that's how it's going to be executing it. I said in the beginning that we're executing line by line, but that pointer that points to the currently executing line can just jump, right? Can go somewhere else, like inside a function that we defined, for example, and just go all right. And to read the second number, we just have to say b equals read number. And we can now delete these duplicated code, and now it's a little bit cleaner, right? It's a little bit smaller. We only have to call this function to get a number. And if I try to run this, as you noticed, we got to type a number. So we got to here. I'm gonna say 10. I'm gonna say, I don't know, 90. And it did compute it. So it did transfer the number that we read from the function to here. Alright, let's play a little bit more with this concept of functions. So let's define a function as before. It just returns an integer. And let's call it sum to n. Alright, so sum to n, and same structure. Right? We're familiar with this. We just return an integer. We have to return an integer. Okay, and this function simply calculates the sum from 1 to a certain number n. Okay, well, let's say int n. Let's say n is 5. Okay, and let's declare a sum here, which is going to be 0. And we're going to just go through 1 till 5 with a for loop. So also we want to declare an I here. I equals 0, actually 1, because we don't care about that. Less or equal than 5, or n in this case. And then I plus plus. Simple enough, right? We just add 1, then add 2, then add 3, so we have to do sum plus equals I. Alright, and then what do we have to do? Well, since it says sum to n, when I use it, let's say here, I say a equals to sum to n, well, this guy should have the sum, should return the sum up until n, right? So what we can do is just say return sum, right? Because that's what we want to use later on in our program. We don't want to return I, because I wouldn't be that useful, or n, because n is just there. So, right, let's just return sum, and let's print it on the screen right here. Print f the sum up until 5 is %d, and then say a. If I run this, simple enough, the sum up until 5 is 15, right? 1 plus 2 plus 3 plus 4 plus 5, that's 15. Cool. But what if I want, I don't know, the sum up until 7, right? I want 7 here. Well, I have to change this to 7, right? Okay, so that worked. Simple enough, right? But I don't want to change the function, right? Let's say that this function is somewhere else in memory. It's not in my file here, it's somewhere else. It's just, right? It's not something that I can change. Okay, how can I control what the function returns? Those are called parameters. And you can add parameters in between the parentheses. So instead of saying int n equals 7, you can just declare here parameters. You can say int n. Okay? And this would force the user to actually add a parameter to the function call. So here's the function call, right? you have to add a number in between the parentheses now, because if you try to compile it, it will complain because, well, too few arguments to function sum to n, right? This guy has one argument, one parameter. So you have to add in here a number. The number, incidentally, is 7 for our example, and now we parameterized our function. If I try to run this, it says the sum up until 7 is 28, and it does exactly what we needed it to, without needing to actually change what is inside the function. Now we only change what is the call for the function. We can change here, like we can say 10, right? And we actually changed what it returned. So now a is 55 instead of 28. See how changing the parameters changes the return value? It's similar to the functions in math. This one, actually, you know, you have f of x. Let me try here. So you have like f of x equals, I don't know, x plus 1, for example, right? So this would be our n, this would be this guy, and this would be our result, which we return right here. Of course, we're not returning x plus 1, we're returning 1 plus 2 plus 3 plus 4 up until x. Okay, I hope that's clear. I hope you can understand what functions are and how can you use that, how you can use them. Alright, so to demonstrate the power of functions, let's try and create a simple algorithm. I want a function that simply prints a message given by a parameter to the screen, but also prints some statistics about that message, like what is the length of that message, how many I don't know, how many letters of A it has, how many exclamation marks it has. Let's try doing that. So first things first, this function will just print to the screen, so it won't return anything. We just have to call it. As I said in the previous lessons, you can actually have a function that doesn't return anything, and that function's return type will have to be void. That's what void comes from. This function won't return anything. And print, call it print message, and then it takes a parameter of type what? It's gonna be a string, so simple char array. That's how you type in a char array, so message, and there you go. So that would be a message, right? Simple enough. And then in between here we're gonna print the message, so printf, just %s and msg, then printf the length, also just extra trans, so that we don't have them on the same line. The length of this message is %d str len msg, and let's try and count how many letters of A it has. How about that? So to do this, we would have a while loop. Let's say a while loop this time. I is less than strlen of msg, I plus always, like that. And in here we have to, well, count how many letters of A. So we will have to have a place to store the number of letters. So let's say count, that's gonna be initialized with 0, and if msg of I is equal to what? Well, letter A, right? So letter A, then we have we should do a count plus, so we add 1 to the count. Also, if msg is equal to capital A, because that's also the letter A, then also count plus. Okay, and down here we're gonna just print f the number of letters of A is %d, and just that's going to be count. Also add in here a percent or backslash n, like so. Okay, and then we can actually use this function whenever you want. Like you can say here print message and just give it a message like hello world. Okay, hello world from our function. Doesn't have any letters of A, so let's try. Yeah, hello world from our function. Yeah, okay, let's try and run this. And I forgot the semicolon, so F11 now. And you will notice that it also printed the message, hello world from our function. The length of this message is 30. I will guess that that is correct. And then the number of letters of A is 0. We don't have any letters of A I kind of wanted to have, so let's, I don't know. How are you? There we go. And you will notice that it also prints the number of A's in our text. So you notice that now we're not returning anything. So we're returning void here. And if I would say int A equals to that, our IDE would complain. So say, okay, well, void value not ignored as it ought to be. Basically, it means that the function doesn't return anything and you shouldn't care about the return value. You don't have a return value, you don't return anything anywhere. You can, by the way, return from a function, so that would just jump back to where it was called, but you cannot give it any numbers here, so you just say return, that's it. Right, so you could do that, you could return right here, for example, and ignore that. It would compile, and if we run this, you will notice that it just says how are you, and the length of this message is 12, because what happened here, it's pretty simple. We called this, and the program said, all right, well, let me find this function for you and give it this parameter. Well, okay, I found it. It's right up here. Here it is. Okay, amazing. And we got here, and the message is, well, let me just get a bigger thing. So we got up here, and the message was the one that we typed below. And it goes line by line from here. It kind of goes like this. And then it sees this return statement at the end. And it simply does, it simply just jumps back to where it was. Oh my god, that's very huge. Why is that so huge? Right, so when it sees that return statement, it just kind of jumps back, and it never gets to this printf statement. That's why we didn't print the number of letters of A in our program here, as you can see. Okay, I hope that's clear. I hope you can understand what void functions are and how you can jump out of a function call. I know this is a little bit more advanced, but you will get used to it once you exercise more and try to use it much more than what we did so far. Okay?